This is the gas loss Fakie tutorial. Milliliters is a volume, so there's my first volume. Here's my first pressure because millimeters of mercury is 1 torr, and that's a pressure. You need to know that that's a pressure, but you can have all this information. None of this is a secret at all. So that's my first pressure. Now, you notice this pressure, my second pressure, does not match because this is in atmospheres and this is in torr, essentially, because remember, that's a torr. So I converted my torr to atmospheres using this ratio here. I could have converted the atmospheres to torr. I just decided to use atmospheres. It doesn't really matter. You can use either one, either kind. You just can't use both at the same time. Here's my second temperature, right? Now, a few things. I can't ever use Celsius in these equations, in this one or this one. I must use Kelvin. So I added 273 to my Celsius. Kelvin is Celsius plus 273. So I added 273, added 273. Now, which equation do I use? Well, there are two possible clues. I don't see anything about moles or grams in here, but if I did, then that would be my clue that I was going to use this one because N is moles. And I know some people are going to say, well, why not use M for moles? Well, small m is mass in most equations in science. So it seems that somebody has decided that N means number of things, and we're going to use moles. I'll get back to that more later. So if I have two pressures and two volumes and two temperatures, or two of anything really, I'm going to have to use this formula here. And I have two of everything in here. Well, if I include the question mark, which is what is the new volume? So I'm going to have to deal with two of everything. So I'm going to put in my first pressure. Remember, this is the pressure converted to atmospheres. My first volume, the first temperature, the second pressure, the second volume is, well, I don't know, that's kind of X essentially, and the second temperature, and the temperatures, of course, are in Kelvin. Then somebody asks, well, does this have to be in milliliters or liters? And for this formula, it doesn't matter. It will work either way. It just depends on, in this case, what do you want to get? I just put in milliliters because I felt like it, and that means what I'll get out is milliliters. Because of, how does this solve? Everything moves through the equal sign on a diagonal if we're only multiplying and dividing, and we are. So this will go down here. This will go up here. And we multiply by the top, divide by the bottom. What we're going to get, though, is atmospheres over atmospheres. That will cancel out. And Kelvin over Kelvin, and that will cancel out. So the only units remaining will be milliliters, and the number I get will be milliliters, and that will be equal to my second volume. So I suggest grabbing a calculator and actually type this in. Something like this, 0.355 times 600 times 373. I wouldn't even hit equals, just keep going. Divided by 353, and here's the trick that some kids don't see coming. Don't hit equals. I mean, you can, but also you cannot. And then divided by 1.5. Now, don't multiply by 1.5. You cannot multiply by 1.5. It will actually get the wrong answer. And then hit equals, and I bet you get 150. And if you want to prove it to yourself about the multiply divide thing, you can try this. This times this times this, divided by that, and then times that, and you will not get 150, and it will be wrong. You can hit equals anywhere along the way, by the way. I don't care. I'm just saying you don't have to. And I think some kids have been coached in procedures instead of sort of math understanding. And I've had kids look at me like, what? You don't have to equals? No, you don't have to. Also, you don't have to consolidate the top and get a number and then consolidate the bottom and get a number and write those down and then divide. I mean, you can, but it seems like the long way to me. I don't care. I don't argue with correct answers. You can do it how you want. I'm just pointing out that my way does work. On number 2, we have a first volume, and I changed it to liters because, look, we have liters here. Now you have to pick one or the other. You can't use both though. And here's also something. I have 2 volumes, and that right there tells me I'm going to use this formula because I have 2 of a type. So here's my first volume. I changed this to liters by pushing the decimal back 3 spots. Here's my new temperature, but I had to add 273 to get Kelvin. The volume changes. Oh yeah, also it actually says change. So if there's a little bit of a story about this, we changed this thing, we increased this thing, we heated or cooled this thing, then you're going to probably use this one. What is the new temperature? I don't know. The new temperature is T2. So if I put in pressure, volume 1, temperature 1, volume 2, temperature 2, you can do it like this. Here's the suggestion though. Solving for the denominator can be a real headache. Why not just turn over both fractions and then you're solving for the numerator, which involves a lot less work and a lot less chance for mistakes. And so then this moves up here, remember, on a diagonal. So we get this times this divided by that, and we get this. But remember, we solved this in Kelvin, and the question said answer in degrees Celsius. To go into Kelvin, we said add 273. So that means to come out of Kelvin, you subtract 273. And so that's what I did here, and I got my Celsius temperature. On 3, I don't see a story about changing. Nothing's increased, decreased, or anything. So also, do I have 2 pressures, 2 temperatures, 2 volumes? I don't see 2 of anything. So I'm thinking it's this formula. Plus, it talks about grams. Well, and then some kid says, but there were never any grams in here. All right, there aren't. But N is moles, and moles is sort of gram adjacent. Let's say it's that, and let's see where we get, because I don't know how to get 2 pressures out of this information, for instance, or 2 volumes. Well, then some kid says, but I don't have any temperature or pressure. Well, we do, because we have standard temperature and pressure, and we're told what this is up here. So they're kind of yelling at us, hey, it's 1 atmosphere and 0 degrees Celsius. Oh, 1 atmosphere and, but I know I have to use Kelvin. So I'll add 273 to my 0 Celsius, and I'll get 273 Kelvin. So that's my pressure. That's my temperature. What's the volume? I don't know. Then we have the real wrinkle in this. You notice, I always know R, right? But I don't know V, because that's the question. And nowhere did they mention any moles. So I know this one, and that one. But I can't solve for V until I know that, because you can't solve for 2 unknowns. It's not in one equation. It's not possible. So there must be a way to solve for N. Let's get N. N is missing, so to speak, in my formula. Can we get it? Well, yeah, we can. We can convert grams of a chemical to moles. We've done it like 100 times. The only other trick is to remember that nitrogen by itself is diatomic, and you might need to look up what those are, but I mean, which ones they are, but they are elements that when they're on their own with their own kind, they make pairs, and nitrogen is definitely one of those. So if we just say nitrogen, we mean N2, which means on the molar mass in the box for N, although we see 14, we know we have 2 of them, so the molar mass of N2 is double what's in the box. It's 28 grams. So I'm going to put in my pressure. What's the volume? I don't know. Here's my moles. Here's R. And remember, if I'm using atmospheres, I must use this R, not that one. That only works if you're using torr. And my temperature in Kelvin. So it's going to be this times this times this. This moves down on a diagonal and ends up under these, but that just means we divide by 1. So I don't especially care this time, because dividing by 1 doesn't help. And then what is the unit? Well, you might remember I said there are technically a bunch of units on the 0.0821, and I just am sick of writing them. But in there is liters. So when everything else cancels out, well, So what we would get if I bothered to write all this out is everything except the liters in here would cancel out, and we would get volume equals liters. I don't especially feel like writing all that out, and you probably don't want to watch it. You can just remember that because you're using these kinds of R values, you're going to get liters. Also, you have to use liters. You cannot put in milliliters for this equation. For this equation, you must use liters. When they calculated R, they thought you were using liters. You must use liters, or it doesn't work. So this times this times this divided by 1 technically is this liters. Now, here's another principle. When we said ideal gas law, which was this ideal gas equation, gas law, what we're talking about is that gases pretty much act the same if you don't do anything super weird. So it's okay to mix the oxygen and add it into the gas with the nitrogen from the previous problem. You can still treat them the same, and you'll get answers that are good enough for the real world. So we could do this one of two ways. And one kid pointed out we could just solve for liters here and add it to liters there. That would work. And that would definitely work. I thought I would do it this way, kind of just because, and it shows something. I thought I would find the moles and add them together. I don't even know which one's easier. You can pick a method, but I'm going to demonstrate this way. So again, I'm at STP. So again, I'm at 1 atmosphere and 273 Kelvin. That means I know R, I know P, T, and the question is, what's the volume? So I don't know that. The hole in my information, again, is the moles, and you can't just borrow this one because remember, we added molecules in there. So the moles have changed. We need to add up the old moles and the new moles. So what is the new moles? Well, we'll take our grams and find the molar mass and divide and get the new moles that we're adding in. The only other thing to remember is that oxygen, again, is one of those diatomic elements. So it's not just O, it's O2. And when you look at the periodic table and you find the molar mass is 16, you have to double it because we have 2 of those in our set. So the molar mass is 16 is 32. Divide gets you the new moles. So we had the new moles plus the old moles is the total new moles now. Then we could take that moles and put it into the circumstances that exist, but it's just the old circumstances. It's still 1 atmosphere. It's still 273 K. And if you're going to use atmospheres, of course, it's the same R. So this times this times this divided by 1 again gives you liters. How do I know it's liters? Well, again, R contains liters, which I didn't show you. You can look it up on the internet or you can believe me. When it solves for V, you get liters because you're using these kinds of R values that we were told. On 5, they want the grams instead of giving me grams. So it's kind of the backward version of 3. And then somebody says, but none of these solve for grams. Well, that's true, but one of them solves for moles. And if I knew moles, I could solve for grams in a minute. So let's look at what we got. We got a volume and a pressure and a temperature. And it's even already in Kelvin, so that's nice. So I'm just going to put this in. I've got the pressure and the volume, and moles is what I'm going to find. Let's see if I have everything else. I have R. Now remember, R needs to be 62.36 if you're going to use torr for your pressure. And then the temperature is 340 Kelvin. Now, be careful because we've all done this wrong. And make sure that you're dividing the correct direction. I want n by itself, so all this stuff is going to move left, but it has to move on a diagonal. So these two end up on the bottom here. So it's this times this divided by that, divided by that. And I suggest actually getting a calculator and actually doing it. And you get this, moles equals N. Moles of what? Moles of chlorine. You know what? Again, chlorine is diatomic. It's Cl2. So when you look at the periodic table, and I'm begging you to use at least one decimal in the molar masses so that it's 35.5, but two of them, that's then 71 grams per mole. This time the grams are going to be on top because I need the moles to cancel out. So don't divide. We're multiplying. And here I get my grams of chlorine. If you read the little story, I have a volume and a moles and a temperature, which I had to change to that by adding 273. Add 273 gives me temperature. And the question is, what's the pressure? So pressure is, I don't know. The volume is 1 liter. The N is 1.40 moles. It didn't say what the unit I should use for the pressure, so I just chose atmospheres because I feel like it. You could do torr if you want. And if I'm going to get atmospheres, that means I need to use this for R. And here's my Kelvin temperature. Again, it turns out that we have something on the left that's 1. So I'm going to move that to the right, and it's going to end up under these 3. But then we divide by 1, so it kind of doesn't matter. So this times this times this, and to be extra picky, divide it by 1, but no one cares. And again, the atmospheres unit was hidden in the stuff that I skipped here because I don't feel like it. And everything else cancels out. So what do I have here? I have a grams. Well, grams. And then somebody says, I know I'm going to convert that to moles. Well, maybe. Let's see here. It occupies 7 liters. And see, that's a volume and a pressure and a temperature. And the reason we can't just convert this to moles is because I don't know what it is. It's an unknown gas. I can't just convert that to moles. Also, what's the question? What is its molar mass? And so the question to ask yourself is, mathematically speaking, what is molar mass? It's grams per mole. So I need some grams figures and I need a moles figure. Well, they told me the grams figure. Okay, so this is going to be 50 grams. What's the moles figure? Well, I don't know. Right, but we do have enough information to figure it out using that formula. Because I have a pressure and a volume, and R, I know is going to be that if I'm using atmospheres, and I have a temperature. And N is an unknown, but I have 4 out of 5 variables. I can solve this. Let's just make sure to do it correctly. We're going to go left with everything because I want the N to be alone. So since we're only multiplying and dividing, or really only multiplying in this case, everything moves on a diagonal. So these two will move left and down, and these two will sit under these two. So it's 2 times 7 divided by 0.0821 divided by 295. And we get this moles equals N. Now, I know in another problem, we converted that straight to grams. That's not the point here. The point is, what is grams per mole? Well, they told me grams over here. I needed the moles so I could divide and get grams per mole because that is molar mass. So 50 divided by 0.578 is 86.5 grams per mole, and that is the molar mass.